we are ready for section 6.2. This is, and we can't remember if we visited this a little bit in Math 3 last year, or if we didn't quite get to it. Some years we do and some we don't. But we're going to talk about inverses of functions, so it may be something brand new for you. And then in the next video I'll tell you about what it means to be one-to-one. So, inverses for this one. An inverse, first of all, let's just talk operations. When you are, hang on, let me scoot over there. When you are solving an equation, let's say 3x minus 2 equals 0, when you are adding 2 to both sides because you see a minus 2, these are called inverse operations. You have done something that is opposite so that it will undo the operation that was being done. When you divide by 3 here, it's because this was multiplied by 3. And so by dividing by 3, you have undone that operation. You did the inverse operation, and that's what we would call that. Okay? So, inverses are when you are doing one thing to undo another thing. So, in that thought, let's look at it graphically. When I see the graph of this is not a function, do you know why it's not a function? It's that vertical line test failure, right? Okay, this is just a relation, but it's just a nice one that we can work with. Graphically speaking, what's happening with an inverse is I am going to take this point here that was at -1, -3, and I'm going to move it to -3, -1. And that is its inverse. Watch again. I'm going to take this point that was at 2, -1, and I'm going to move it to -1, 2. Are you catching on? Let's see. This point is at 1, 2, 3, 4, 3. And I'm going to move it to, do you know where I'm going? That's right, 3, 4. And that is its inverse. So, oh, I missed one. This one is at 0, 1, and I'm going to move it to 1, 0. Well, now that we kind of have an idea of where these are moving to, look at the inverse. Oh my, I just connected those in entirely the wrong order. Don't do it that way. Connect in the right order. Oh my gracious. Okay, so here we go, here we go. Oh, I missed. Guys, I'm going cuckoo. Here we go. Goodness, what a sloppy graph. Need my dry erase board. This dark line is the inverse of this lighter one. Now, so what happened? Graphically speaking, the x and y coordinates switched places, right? Switch. Did you notice I didn't change their signs or anything? The -1 stayed -1 and the +2 stayed +2, but they switched places. So all my xy's became yx's. Okay? But what else is happening here is, get another color. What's also happening here is I have this line. Oh gracious. If I had more time in my day, I would just redo this, but you know what? I do this on the board all the time, so here's my line y equals x. What's also happening here is that this thing, this inverse, is a reflection of the original over the line y equals x. Now if you drew yours neater, then you probably can see it a little bit better. but they are reflections over that line. So it reflects over y equals x. The line y equals x was one of our 8 basic functions that we were using our hands to show what those graphs look like. Okay, so that's one that you should have in your head. So I have my original relation. It wasn't a function, but I can still call it f. And my inverse is called f inverse. This is going to be a video for the record books, boys and girls. Alright, f inverse has a little -1. It looks like it's an exponent. It's not, it's just a notation, but that means inverse. Alright, so since this is what happened graphically speaking, algebraically speaking, we're going to do something similar. We are going to switch the x and y variables, and we're going to solve the equation for y. So that's what happens algebraically. Graphically, the xy coordinates switch places and it reflects over the line y equals x. Algebraically, we're going to switch the x and y variables and we're going to solve for y. So now that we've seen it graphically, let me show it to you algebraically. Look at this guy. We're going to start with a pretty function, and these will be functions that we're going to use now because I want them to work out in a specific manner. Okay? So I have f of x is 4x plus 2. And look at all of these instructions up here. Oh my goodness, what is all of that about? It says find f inverse. So that's what we're looking at right now. See how it looks like it's to the -1. And then we are going to graph f, which is this function, f inverse, the one that we find, and y equals x, that diagonal line, all on the same axes. So that's what we were just doing a second ago. So we're just going to do it with functions this time. Alright, remember our rule? Switch x and y, solve for y. So f of x really means y, doesn't it? So it's really this equation. I'm going to literally, I'm telling you, switch, I hate pencils, don't you? Switch x and y and solve for y. So I switched x and y. Now I'm going to subtract 2. I'm going to divide by 4. And guys, I'm going to divide each piece by 4 so that I get, and 2/4 is 1/2. Oh my. If you don't know what that came from, you need to do this on your own. Hit pause and solve this equation on your own. You know, in class you can't hit pause. Isn't this nice? Hit pause and think through dividing everything by 4 individually. Okay? Here's our new equation. This is f inverse. Alright? So our original equation, f, do you know what that looks like? It's a line. It goes through 2, and then where do I go? Up 4 over 1, or I could even go down 4 and over 1, and I can make a nice line. Somebody get a ruler. That's f. F inverse, get another color, is a line. How delightful. This line goes through -1/2, and then I go up 1 over 4. Or I can go down 1 and left 4, and that makes another line. You ready for this? The last thing we need on this graph is y equals x. See if I can get these in there nicer. There we go. Y equals x. Let me label this. This is f inverse. Oh, how fun. Oh, you can't see the difference between my pen and pencil very well. I'll grab another color. Yay! So I have graphed f of x and the inverse and y equals x. Tilt your head for your paper. You see it? It's a reflection. Alright. All I did was I switched x and y and I solved for y. That's it. That's the rule. Rule of the day. Let's do that again. Let's change it up a little bit. This one's not a line. Do you see what it is? It's a parabola. But we're going to do the same thing. Now look at this mathy goodness over here. We're going to talk about that here in just a second, okay? But first I want to start with the fact that f of x just means y. So I switch x and y, and I'm going to solve for y. In order to solve for y, I need to subtract the 4, and I need to take the square root. There, I've solved for y, so that is my inverse. Here's my original, here's the inverse. And we're going to graph both of those. But first a note about this whole x is greater than or equal to 0. Normally x squared plus 4, remember the transformation that's occurring there? The transformation is up 4. So I'm taking my x squared and I'm moving it up 4. And so it would go this way and up through negative 1, 1 this way. But it says x is greater than or equal to 0. So they don't want you to use this part because that's not where x is greater than 0. I only want this half of it. So I'm just going to not look at that piece. It's only this piece. Now why would they say that? Because when I come down here and I graph this, you remember square root of x? Square root of x normally just like this. Remember that? I'm going to move it to the right 4. Here we go. 1, 2, 3, 4. And it's going to go 1, 1, and then 4, 2, like this. If I want this, my f, and this, my f inverse, I need to make sure that I only use this half of it, or else it's not a true reflection. Here's y equals x. Take a look. It's a reflection. Can you see it? Oh, isn't that neat? Alright, we're going to do that one more time, and that's why the mathy goodness. Just because they don't, normally we would say plus or minus the square root if we were taking a square root, and that would give us 2 of them, and I don't want both of them. So, lots of stuff going on there. One more time. Oh, it even says one more time. Oh, you're excited. This is a good one. Remember our rule. Switch x and y and solve for y. Here we go. X equals 1 over y minus 2. How am I going to solve this thing for y? Well, I'm going to get rid of this in the denominator. This is a quantity. That cancels and I get 1, which is not usually an issue. But over here, I'm going to distribute the x and have xy minus 2x equals 1. Did you see how that worked? I distributed the x because this is times this quantity y minus 2. I need to solve for y. So I'm going to add 2x, and I'm going to divide by x. There. Now, some of you are saying, but Miss Noble, when I divided by x, I got 1 over x plus 2. Yes, and you can have 1 over x plus 2, but I think you're going to find that it will be easier for you to graph it this way. Because what we're going to need to think about are rationals. So we have vertical asymptotes and horizontal asymptotes and x and y intercepts. Oh, you thought all that stuff was gone because you took a test, didn't you? It's not how it works. Alright, let's graph our function. Vertical asymptote, horizontal, the x-intercept. and the y-intercept. That's what I want to look for, and then we can sketch a graph. Where's the vertical asymptote? 2. Where's the horizontal asymptote? First terms only. 1 over x, and x is going to infinity, so 1 divided by a giant number is 0. What's the x-intercept? Well, that's where y equals 0, which it turns out is where the numerator is 0. Remember our last section, we decided the numerator equals 0 is where it's at. Is 1 ever going to equal 0? No. So there is none. For the y-intercept, it's where x equals 0. So I have -1/2. When you draw these, you need to be plotting them. Plot. So vertical asymptote at 2. That means get in there and put the asymptotes on your graph. Horizontal at 0. Put him on there. Plot in the -1/2. I have decisions to make. I have 2 curves because I've got one on either side of this vertical. So when I'm over here on the left, is it going to be above or below this 0? Well, it's going to be below. Use the asymptotes to guide. There it is. When I'm over here, because this one was down below, in all likelihood this one is above. How could I double check that? I could put in a value over here. Let's say I put in x equals 4. If I put 4 into my function as my x value, it would give me 1 over 4 minus 2, which is 1 over 2, which is here. It is above. Oh, I'm a good guesser. All right. That is F. For F inverse, I really would like to switch colors. I think it would be easier. Oh good, I have a purple. Here we go. It would be very beneficial to you to also switch colors. It's going to get kind of rowdy here in just a second. We're going to go vertical, horizontal, x-intercept, y-intercept. You want to go find those real quick? Hit pause. Vertical is in the denominator, 0. For the horizontal, did you take the first terms, the highest terms, the leading terms? 2x over x reduces down to 2. X-intercept is where the numerator is 0. The y-intercept is where x equals 0. Uh-oh, now I'm taking 1 divided by 0. Let's just stop here before we graph this. Look what happened here with the asymptotes. Oh, you see it? Look what happened with the intercepts. Whoa! Guys, when we switch the x and the y, the asymptotes get switched, the intercepts get switched, the whole graph switches around. So my vertical is at 0. The horizontal is at 2. X-intercept is -1/2. Now, train your brain not to look at the other curves on there. Look at your asymptotes and this point. That means on this side, it's going to be below the 2, but approaching it. I can't see where I'm going. Here we go. Approaching the asymptote. And over here, you see this quadrant up here? I could plug in 2, and 2 would give me 1 plus 2 times 2 is 5 halves, so it'd be 2.5. There's a point for me. Did you see how that worked? I plugged in 2 in here, and I got 5 halves, which is 2.5. So it gave me a point so I could have something to plug into. Alright, you ready for the magic? Here comes the line y equals x. And now I want you to tilt your head or tilt your paper and look at those two curves. See how they're a reflection over the line, y equals x. Wish that one was just a little darker. On the board I usually do this in 3 colors. It's easy to see. See? How nice! Alright, so that's inverses. That's going to take some practice, isn't it? But that's okay. I want you to go ahead and go to the next video and see what 1-to-1 means. It's just one more little thing to add to this, and then you're ready for your 6-2 homework. And I will probably have an open-ended part for you so I can see your graphs on those. That would be kind of a nice little thing. Alright.